Alright, let's go ahead and get into our fourth episode of the sed implementation in Haskell. No, it's been a while since the last episode, and this is shaping up to be the slowest developed project in history. But hopefully we can make some headway, and hopefully y'all are still enjoying it. I do enjoy working on it, I just haven't had a whole lot of time. I'm going to make some quick changes right here. I'm going to rename this input to zipper. We implemented this last time, and I just think zipper is a better name for a zipper than input. So I'm just going to rename that real quick. And I also want to separate out this main function into its own file so that we can have kind of the executable portion of this program in a different file. So I'll need to import sed here, and we also need the TIO interact. And the end goal for this episode is going to be to make a parser that will parse a list of commands from a string. So instead of having to type out these commands in this fashion, we can use the actual sed syntax with our sed function. So to get started on that, I'm just going to delete this, and let's pretend this is a working executable here. And it's just going to take the first argument of our executable and pass it in. So to do that, let's make this a do block, and we can make args be get args, and we need to import that from system environment. But now our sed function is not working because this is giving it a string, and it wants a list of commands. So we're going to have to change our sed function now to be what we originally intended, which is something that works just like sed does and takes a string. So we'll make this s, and then let's define the command string here. We're going to make a function called parse sed that will take the string that we pass in and then return a list of commands. So that is going to be the task for this episode. To do that, let's make a new file called parser.hs, and we'll make a new module called parser. And we can import the Text.Parsec library and Text.Parsec string to help us with this. So let's start by just making a mock parse sed function which takes a string and returns a list of commands. And we'll just put a little placeholder here for now since we don't know how to make it yet. And it's telling us that command is not in scope. So we could import sed here, but it doesn't make sense to me to really do that. Since the commands are originating from this file, it makes more sense to me to move the definition of the command types over into the parser. So then we need to, from our parser, import the parse sed function and the commands. There we go. Alright, so to get started, I always like to start as simple as possible, especially when I'm doing something complicated. And the thing that seems really easy to do here is to make a function that will parse the print command. So I'll make a function called parse print, and it's going to be a parser that returns a command. And we know that the print command in sed is just one character, it's the letter P. So if we get the letter P, then we want to return. So the return will wrap it in parser, and we're going to return the print command. So that was easy. We know that the delete and next functions are pretty much the same. So I can just copy that line and use a substitute command to switch this from print to delete. And we can use the same thing to switch this to next and change the characters. So these don't have type signatures here. So we need type signatures. We'll just add them here. And there we go. Now the parse substitute function is going to be a little bit more tricky than the other ones, because we know that in sed the substitute command is not a single character. It's an S followed by a pattern, followed by a replacement string, followed by some flags. So Parsec makes this kind of thing really, really easy. First we want to match a character S, then we want to match a delimiter. We could just put character / right here, but we want to allow people to use whatever delimiter they want, including like pound signs and stuff. So let's just make a declaration of what the allowed delimiters are, what they are, and we can just put all the symbols in here. And I'm basically just going to insert all of these symbols that aren't pairs, like parentheses and open and close brackets and things like that. But all the other things are fair game, except for \, because that just makes things complicated. So now, instead of doing char of this, we can say one of the delimiters. And we also want to store that, because if they start with one delimiter, they shouldn't then be able to use a different delimiter. That's the whole point of the delimiter. So we need to store it as delimiter so that we can then match it later. Now we need to match the pattern, which is going to be basically many, which is a lot, more than one, of anything that's not the delimiter. So we'll do satisfy not equal to delimiter. And then we'll do, we'll match the delimiter again. And then we'll do the replace string, which will be the same thing, many that aren't the delimiter. And then we'll do the delimiter again. And then we'll do the flags, which flags, for now we can just do satisfy, make sure that it's a letter. So is alpha. We need to import that from data.character is alpha. And then we can return the thing we came for, which is a command, substitute pattern replace flags. There we go. So now let's make a function that will parse a command. So this one will parse a command regardless of whether it's print, delete, next, etc. It'll try to do each of those, and if one of them matches, then we'll return that. So it's going to be a parser that returns a command as well. And parse command, you can make a do block. It will return parse print, or parse delete, or parse next, or parse substitute. And let's store this into command and then return that. Let's see, redundant do. And we also want to make sure that if there's white space surrounding these, that's allowed. So we'll match many of white space around it. There we go. So now our do is not redundant and everything is happy. Now let's make a function that parses all of the commands. So instead of just one, it's going to parse a list of commands. This will also be in do notation. And this one, Parsec has a function called sep_end_by. So we can look that up on Google, sep_end_by. And as you can see, it takes a, well, it's a little bit complicated looking actually. It might be better if we go to the documentation here. So let's search for Text.Parsec Haskell sep_end_by. Here we go. So sep_end_by p_sep parses 0 more occurrences of p separated and optimally ended by sep. So we can use this to try and parse 0 or more occurrences of p, which will be our parse commands function, and then separated and optionally ended by sep. So that'll be a delimiter between commands. So we can use, let's see, sep_end_by, and then we'll have our parse command function, and then we need a delimiter, so a way to separate these, and we can just make that a parser that matches a semicolon like sed does. And let's see. So we don't even need the do notation, we can just do it like that. Awesome. Then our parse sed function, we can actually use the parse function to run our parser, and our parser is going to be the parse commands parser, and then it takes what does it take? I've forgotten. Let's search on Google again. Parse. Okay, so right here it takes a parser and then a source name and then a string, I think that is. So the string is going to be the string that we feed into the parser, and the file, I think we can just use a empty string or empty array, because it's just used for error messages and we're not quite there yet into handling errors. So this returns an either, so it'll be either left, and if it's left we're not going to deal with the error yet. And if it's right, then it should return us what we want, which is all of the commands. So I'm being kind of hasty here, and I wrote a lot of code and I haven't tested any of it, but let's see if it works. I can load, let's see, oh, I need to move into this directory, and I can start GHCI and try to load parser. And then I can do parse sed, and let's say npds pattern replace flags. Dope. Okay, parse error on input semicolon. So why is this not working? Sep_end_by is giving us trouble, of course. Well, before we try and troubleshoot that, let's see if it works with just a regular old character, and it does not. So, couldn't match character with list of characters in the first argument of parse sed. Oh, needs a string. Aha! And here is our problem, I think. We are trying to show commands, but we have not derived show. So, deriving show. And we need to load it again. And it works. Parse said next. Okay. You know what? I think earlier when we got that first error, I put it in single quotes. I am not always the brightest tool in the shed. Wow, and it works. Next, print, delete, substitute pattern, replace flags. It's exactly what we wanted, so our parser is working. Excellent. So now we should be able to do run GHC of main, feed it our first argument, so say print 3 times, and then we can feed it a file like test this out, and it prints each of the lines 3 times. Now something is wrong here though, and that's that by default sed should print, and this does not. By default it is not printing, so it should have a print in there by default, and that's if the that's basically if the in flag, the -in flag, is not supplied to sed. And we don't really handle any of the arguments here yet, but you know, if we wanted to, we could just add print here, but right now I'm not too worried about it. Maybe we'll tackle adding some flags and other things like that in the next episode. Right now I'm pretty happy with our parser, and I hope you've enjoyed this short episode, but full of content, and I hope to put out another one soon. Thank you very much for watching, and I hope you have a great week.